Alright, welcome to the video on the double angle identities. Alright, so this first example I want to do is say, well, let's find the sine of 2x. Alright, well, we know that we could rewrite the sine of 2x as the sine of x plus x. No problem with that, right? Then from our sum of two angles formula from the previous video, we could rewrite this as what? Well, sine of the first angle times the cosine of the second angle plus the cosine of the first angle times the sine of the second angle. All right, that just comes from the sum of two angles formula from the previous video for sine. Okay. Well, now what do we have? Well, we got the sine x cosine x plus cosine x sine x. Those are the same thing, so this just goes to 2 sine x cosine x. That's it. So sine of 2x can be rewritten as 2 times the sine of x cosine of x. Everybody see how that works? Here we've got the sine of 2 times an angle. And it turns out that that's the same thing as 2 times the sine of the angle times the cosine of the angle. All right? We'll summarize this up in just a second. Let's look at the next one. All right, cosine of 2x. Same idea. We could rewrite this as the cosine of x plus x. And then, using our sum formula for cosine, cosine of the first angle times the cosine of the second angle. Then minus sine of the first angle times the sine of the second angle. Alright, so that just goes to cosine squared x minus sine squared x. Everybody see that? All right, well, that's our next identity. The cosine of 2x is equal to cosine squared x minus sine squared x. Right? That's one of them. It's actually... And again, we'll summarize all these up in just a second. Okay? All right. Well, also, this could be equal to, well, cosine squared x could be rewritten as 1 minus sine squared x. Everybody agree with that? Cosine squared x is the same thing as 1 minus sine squared x from the Pythagorean identities, right? And then we have minus and then a sine squared. And so all of this just goes down to, what is that, 1 minus 2 sine squared x. This would be another identity that cosine of 2x is equal to. So notice what we have. Cosine 2x can be written as the difference of cosine squared x minus the sine squared of x. So you need to know both the cosine of the angle and the sine of the angle. Or cosine of 2x can be written as 1 minus 2 sine squared x, and therefore you would only need to know the sine of the angle in order to figure out what the cosine of twice the angle would be. Okay. Well, there's one more. I'm going to come right here again. Okay. Equal. We rewrote cosine squared as 1 minus sine squared, right? Well, we could just as easily say, well, let's rewrite sine squared as 1 minus cosine squared, right? So you need parentheses and it'll be 1 minus cosine squared x, right? I mean, I'll put a big or up here, okay? All right, so what does that go to? All right, so that goes to cosine squared x minus 1 plus cosine squared x, which goes to 2 cosine squared x minus 1. So we've got a third identity that cosine of 2x could be written as, right? So cosine of 2x can be written in one of three ways. Doesn't really matter which identity you want to use. Okay. If you want to use this first one, then you need to know both the cosine of the angle and the sine of the angle. If you want to use the second one, then you need to just know the sine of the angle, right? Or if you just want to use the third one, then you need to know just the cosine of the angle. Any of those things will let you know what the cosine of twice the angle would be, right? So in summary, here we go. This is first one, second one. Right, and from the second one, this is A, B, and C. Right, so those are the three formulas. I'm going to add this other one over here, the tangent. This is number 3. This is the identity for tangent of 2x. We're not going to derive it. You can if you want. All right, you don't need to memorize the tangent of 2x identity, but you do need to know the sine of 2x, what that goes to, and the cosine of 2x, what that goes to. Right? You must know those off the top of your head. In fact, for the cosine 2x one, I encourage you just to remember the first one, because from the first one up here, you can always derive the other two fairly quickly. Okay? All right. But again, if you want to memorize all three, that's your call. But we need to know the sine of 2x and the cosine of 2x identities. All right, so here's an example. If cosine of theta is negative 4/5 and the sine of theta is greater than 0, then we want to find the sine of 2 theta and the cosine of 2 theta. So let's do A first. Sine of 2 theta goes to 2 sine theta cosine theta. So in order to find the sine of 2 theta, we need to know what the sine of theta is and what the cosine of theta is. Well, we already know what the cosine of theta is. It's negative 4/5. That was given to us. We do not know what the sine of theta is, so we need to go figure that out. Right? Well, you got several ways to do it. One way is to draw a little triangle, right? And say, here's theta, right? And if cosine theta is negative 4/5, cosine is adjacent over hypotenuse. Okay, I'm going to leave off the negative sign here because really, what quadrant is theta in? In fact, I'll just put it up there. Theta is in what quadrant? Right? Well, if cosine's negative and sine's positive, that's quadrant 2. Right? You need to know what quadrant your angle's in. Right? So now we just go off to this, and that's why cosine theta is a negative number. Right? So you just need to know what the 4 and the 5. That'll let you figure out that the hypotenuse here needs to be 25 minus 16 is 9, so it'll be 3. And therefore, the sine of theta is equal to 3/5, opposite over hypotenuse. Everybody see that? Okay, so now we can go figure out what the sine of 2 theta is. So we have 2, sine of theta is 3/5, cosine of theta is negative 4/5, and so sine of 2 theta goes to negative 24 25ths. All right, everybody see that? All right, so now what about the cosine of 2 theta? Since we already know the sine of theta, we could use any of those three identities. Okay, but this time I'm just going to go ahead and choose the cosine one. So we have 2 cosine squared theta minus 1, and just use our little negative 4/5 that's up here. So we have 2 times negative 4/5. That's the cosine of theta, but we're going to square that because it's cosine squared minus 1. So that would go to 32 25ths minus 1, 25 25ths. And so that whole thing goes down to 7 25ths. Everybody see that? All right, so if the cosine of theta is negative 4/5 and sine of theta is positive, then the sine of 2 theta is negative 24 25ths, and the cosine of 2 theta is 7 25ths. All right? So that's kind of the idea. Sometimes you might need to go off and do a little triangle or some identity to figure out, sine theta or cosine theta, whatever else you need, what other information you need, right? And then the rest is just knowing what these identities are, and then just plugging in the values that you need. All right. All right. That's it. Study well. Please let me know if you have any questions.